Today, ladies and gentlemen, we're going to take a look at rational functions. We're going to find asymptotes, we're going to find holes, and we're going to even be able to come up with a pretty decent sketch of what the graphs look like. Let's get started. Well, ladies and gentlemen, we have ourselves here a rational expression. How do you know it's rational? Well, because it's got a ratio, right? There's a numerator, there's a denominator, there's a ratio between the numerator and the denominator. First of all, anytime the denominator is equal to 0, you're going to find that you have an asymptote. So there is going to be an asymptote right here at 1. Okay, what does that mean? Well, it means it kind of helps us sketch the graph. Are there any holes? No, there's not any holes because we don't have any factors on the top and the bottom of this rational expression that exactly match. And don't worry, I'm going to do about 5 or 6 different examples and whip through them. So all we have here is an asymptote at x equals 1. Now, let's talk about another asymptote. Well, if the degree of the bottom is larger than the degree of the numerator, and that's what you have here. This is degree 0 in the top, and the bottom is degree 1. Anytime the bottom has a greater degree, there's also another asymptote, and the asymptote is at y equals 0. All right, so now we have an idea of what this curve looks like. And you could plot some points, right? You could plug in some numbers besides 1. You cannot plug in 1. But you could plug in some numbers to see what this graph looks like. But the graph kind of resembles this. Now, I'm doing a very poor job, as you can tell, sketching this graph. Very poor. But it gets closer and closer to the asymptotes, x equals 1 and y equals 0. Well, first things first, if you could factor a rational expression, factor it. Now, if you look at the denominator can be factored because numbers that multiply to be 2 but add up to be 3, it's x plus 2, x plus 1. All right, so we factored it. And now we could start looking for some things like we should look right away to see if there's any holes. And it turns out there are holes. Let's see, can I get red going? Let's try it. So you'll notice that the factor in the numerator, x minus 1, matches the x minus 1 in the denominator. So now when you're looking at this function, this rational function, it looks like this after you get rid of the common factors. Okay, but first of all, what's going on? When we remove this common factor of x plus 1, set the factor that cancels or reduces, set that equal to 0. Because you want to know what the heck is going on with that thing. And if you subtract 1 from both sides, you see this. This is called a hole. There is a hole in the graph, and I'll talk about this in a second. Okay, now there are no more common factors in the top and bottom. So back to the first example. You set the denominator equal to 0, and doing some really simple algebra here. Subtract, and you get this, which is an asymptote. Okay, so let's see. Oh yeah, by the way, the denominator has a greater degree than the numerator, so we even have another one. We have y equals 0 is another one. Okay, so let's sketch that. So there's an asymptote at -2, and it's vertical. And then the y equals 0, that's horizontal. So we've got that. Now, let's sketch it. So now that we know what this curve looks like, and again, if you plot some points, like you plug in some numbers, and you can kind of tell if it's above or below the x-axis really easily, but just by plugging in some numbers, you're going to see that the right side, let's see, I'm trying to do this as skillfully as I can. Better than the first one. Yeah, I think I did it. better than the first one. Okay, so you have that, and you have this. Yeah, that's about as good as it gets. Okay, so you got this, right? You got our asymptotes. Now, how do you do the whole? Right? If you plug this into a graphing calculator, you'll see something like this. And of course, you're not going to see the asymptotes, but you'll see a curve that roughly looks like this. But what does the whole mean? So if you look at x equals -1, there you go. Hey, look, x equals -1. So now I'm going straight up to find the graph, because I was looking down here. I'm like, hey, the graph can't be over here. So if you look up, you're going to find the graph is over here. And that means there's a hole over here. There's a hole in the graph. You'll never see that in the graphing calculator. And there you go. You got yourself a pretty rough looking sketch. So I chose this third example for a reason, because it's a little tricky. Let's say we were to factor that denominator. And you're looking for numbers that multiply to be 3, add to be 6. And it's 3 and 3. Okay, so now you have it factored. Now what? Well, you can see that there's a factor in the numerator, there's a factor in the denominator, they both match. It's a common factor. So what are you doing? You're really reducing a fraction. So you reduce the fraction, and you're left with 1 over x plus 3. But keep in mind, we just took x plus 3 and reduced it. So to find the whole, it's always a technique to find the whole. When you reduce a fraction by a common factor, it locates the whole. So now we know there's a whole. That's why I'm putting a little h here for whole. Okay, then you set the denominator equal to 0. Why? Now we're finding the vertical asymptote. And this is where a lot of students get confused. And they're thinking, well, what the heck? I've got a hole and an asymptote in the same spot. So remember, what the heck is an asymptote? An asymptote is a vertical line, or at least in this case, it is vertical. And the curve cannot exist anywhere over there, because you can't have a 0 in the denominator. It's a big no-no in math, and you should know why at this point. But that's why the graph does not exist over here anywhere. X can never be equal to -3. That's why we say that there's a hole. Okay, so now that we know that there's a hole there, or I'm sorry, an asymptote there, and you're thinking, well, how do I put a hole there? Because I'm going to try to find the graph, but the graph doesn't exist. And there you go. So that means if you ever see a duplicate where there's a hole and an asymptote together, you know that it cannot be a hole. It's only an asymptote. That's a little tricky. But when you consider what the graph looks like, it kind of does make sense. So now we know that there is an asymptote, a vertical asymptote at x equals -3. We also know that the denominator has a greater degree than the numerator. So we've got now a horizontal asymptote, another asymptote, but it's horizontal at y equals 0. So now let's sketch it. Plugging in some points, we could see again that our graph, if I'm going to try to do this as best I can freehand, yeah, not too bad. Okay, it's going to look like that. And now this one, yeah, not too shabby. And there you go. We've got our graph. On to the next one. First things first, factor. So let's factor that denominator. Looking for two numbers that multiply to be -14, add to be -5. So you're going to get x minus 7, x plus 2. All right, notice there's no factor in the numerator that can reduce with a factor in the denominator. So there's no hole. All right, so there's no hole or holes in the graph. Now all we could do is set the denominator equal to 0. So if we set this entire denominator equal to 0, well, that means each one of these factors has to be equal to 0. That means we're going to get a vertical asymptote at 7 And we're going to get a vertical asymptote at -2. So we really do have two vertical asymptotes. And there they are. And let's graph. Now, earlier I was looking at this graph and I was like wondering, how does this thing look? And you've got basically three sections: a left section, a middle section, and a right section. So I wanted to figure out what was happening in the middle. So I thought, well, if I were to put in 0 here, just drop in the number 0, just to see, is the graph going to be above or below the x-axis? You get 3 over -14. That's a negative number. So it's down here. So you're basically getting some function that's down here, and it's going to follow all the asymptotes. So you're going to get a sketch that looks like this. And man, it's raw, right? It's a rough sketch, so don't take this. It's going to look a lot smoother like this smoother than this if you put it in a graphing calculator, but it's okay. You're just getting a rough sketch. Okay, and now everything over to the right, again, if I were to plug in a number like 8 into this part, into this function, I'm going to get a positive number on top and get a positive times a positive. Everything's positive. So that's why I know the graph has to follow, it has to follow it like this. Okay, I didn't talk about the horizontal asymptote, but clearly the bottom has got a greater degree. So that's why there's an asymptote here on the x-axis. And again, I wanted to see what was happening over here left of -2. So like if you put it in -3, you're going to get a negative times a negative. That's the bottom is positive, positive divided by positive. So it's all positive up here. So you're going to see something that looks, again, like this. Not too bad. Not too bad freehand. And there you go. No holes. 3 asymptotes, 2 vertical, 1 horizontal. Next problem. All right, another example. Well, I'm going to factor that numerator. You could factor out a -5, and you get this. And the denominator is that. Boy, that's a little wonky. All right, but anyway, you get this, right? So are there any common factors? Nope. X minus 6 is not the same thing as x, so this means there's no hole. All right, now we move on to the next portion here, and we set the denominator equal to 0. If you set that denominator equal to 0, you get our vertical asymptote. There you go, vertical asymptote. If you ever get the numerator and the denominator the same degree, because that's degree 1, that's degree 1, what you do is you take the leading terms, and what you do is divide them. And that's what I want to do. So if I put this over this, you're going to see that you're going to get a y equals -5. And that's going to be your horizontal asymptote. And now I got these two asymptotes. Now I want to sketch this thing. So on the right side of the graph, close to 0, it's positive. Put in a number like, I don't know, 2. You're going to see that you're going to get a positive value. So that means it looks something like this. Now, don't hold me to this thing because I'm not graphing it well. I don't have the correct 0. It should be 6. But I'm just trying to sketch this real quick. Now over here on the left side of the graph, if you were to put in a number like -2, you would see that not only would it be negative, but it would be below. Your answer would be less than the -5. So it has to look something like this. Okay, and that's your graph with no hole, 2 asymptotes, 1 horizontal, 1 vertical. So here's MATHguide.com. This is the website that I use for lessons, interactive quizzes, and of course videos. I put those on here. But I wanted to show you an example I have here for an interactive Quizmaster where it throws you a random problem. You've got to factor this. You use the factors, and you go, hey, it's got 2 factors in the denominator, which means it's going to have 2 vertical asymptotes. And so you could see that this is very interactive. If you choose the wrong answer, it gives you red text, and it'll remind you, hey, I got to go back there and I got to fix some stuff. And so it's very interactive. And that's why you should use MATHguide products. So make sure you go back to mathguide.com, check out all of our lessons, interactive Quizmasters, and instructional videos. You will not be disappointed. Now, this whole lesson today was on rational expressions, a ratio. I wonder in math if there is a irrational function. No. Why would you think that? Everything in math is logical, orderly, there's, at least until you get to the graduate level, then it gets... Okay, you've been warned. Okay, just go to MATHguide, man. Check out our free stuff. It's all free. Free is good. Enjoy.